Alright, stoichiometry. In this topic, we're going to be looking at ratios of molecules in chemical reactions and using them to predict the amount of reactant used up or the amount of product produced as a result of a chemical reaction. Remember, a balanced chemical reaction tells you how many actual particles are required of each type and how many actual particles are produced of each type. So when I say 2H2 plus 1O2, that means I have two H2 molecules combining with one O2 molecule to produce two water molecules. Since moles is a representation of the number of particles, if 212 represents the ratio between the number of particles, it also represents the ratio between the number of moles of each item in the reaction. So for example, if we look at this reaction, if I had 5 moles of H2O, how many moles of O2 would be, this should say, used up? Or how many moles of H2 would be produced? Well, if I had 5 moles of H2, if I wanted to know how many moles of O2 would get used up, I know my ratio is 2 to 1. For every 2 hydrogen molecules, or 2 moles of hydrogen that get used up in this reaction, I use up 1 mole of oxygen gas, or 1 particle of oxygen gas. So here I said I had 5 moles of NH2. So if I bring the NO2 up here, then I could see that I would use up 2.5 moles of oxygen gas. If I did that using the factor reduction method, what I could say then is that I have 5 moles of H2, and I want to convert that into moles of O2. For every 1 mole of H2, I get 2 moles of H2. And so I see that my 2 is on the bottom. These cancel out. And I get 2.5 moles of O2. So this is using a ratio, like you might have done in your grade 9 math class. And this is using the factor reduction method. I think this is the easier way to think about it in this particular situation. One more time, if I have 5 moles of H2, how much H2O will be produced? So my H2 is going away, my H2O is being produced. For every 2 moles of H2 I have 2 moles of H2O. 2 over 2 is just 1. And so I'm going to get 5 moles of H2O. One more time, the balanced chemical reaction, it gives you the actual number of particles or the number of moles that must be combined in different ratios for the chemical reaction to occur. For example, 2 molecules of H2 have to react with 1 molecule of O2 to produce 2 molecules of H2O. And since molecules and moles are the same thing, or there's representations of the same thing, if that's the ratio for molecules, it's also the ratio for moles, then I can use that to set up ratios or to convert the number of moles of one substance using the balanced chemical equation to the number of moles of another substance. Let's look at an example that goes all the way through the whole process. So the whole point here is that we can predict the mass of products or reactants used or produced in chemical reactions. So magnesium, as a solid, is being used to displace copper out of a solution of copper 2 chloride. So that would mean 2 plus on the copper, 1 minus on the chlorine, cross them over, so copper 2 chloride. They're displacing copper out of the solution, so this is a single displacement reaction, and as a result, it's producing magnesium chloride. 5 grams of magnesium is used. How much copper can be produced? So I have 5 grams of magnesium, and the question is how much copper can be produced? Remember that this 5 grams represents the actual mass, and this chemical equation, which is balanced as is, represents the relationship between the number of particles, or the moles of particles, in the chemical reaction. And so to do any sort of calculation with this, I need to change this 5 grams into a number of moles. I can say that moles is equal to mass over molecular mass, or I can convert from mass, dividing out the mass, to produce moles to figure this out. In 1 mole of magnesium atoms, I have a mass of 24.3 grams, and so it's 5 divided by 24.3. Or if you prefer, I have 5 grams of magnesium divided by the 24.3 grams per mole molecular mass, or molar mass of magnesium, to say that that 5 grams represents 0.206 moles of magnesium. Magnesium is in a 1-to-1 ratio with copper. So that means for every 1 mole of magnesium, I have 1 mole of copper. Or for every 0.206 moles of magnesium, I'm going to get 0.206 moles of copper. Now I want to convert that moles back into a mass of copper. So that means I want to divide out moles on the bottom and produce grams on the top. And that means I need the molar mass of copper. Molar mass of copper is 63.5. So there's 63.5 grams of copper in every 1 mole of copper. Those two ended up being multiplied together. So I get 13.1 grams of copper. That was a 1-to-1 ratio. Seems like we better do an example that doesn't have a 1-to-1 ratio, but that gets you started. If you prefer, just to reiterate this step in another way, I could have said the number of moles is equal to the mass divided by the molar mass, which would have been 0.206 moles equals the mass divided by the molar mass, which is 63.5 grams per mole. So the mass is equal to, and then you end up multiplying to get back to your 13.1 grams of copper. So stoichiometry is when we use balanced chemical equations to determine the ratio between moles or particles of substances in the chemical reaction. So we can use that, if given moles, to determine the number of moles of other things that will either be used up in the reaction or produced. Or if given the mass, we can go from mass to moles and then use the ratio. So from mass to moles, and then use the ratio to predict the amount of a product that would be produced in that given chemical reaction.